sir. Good, sir.
Fine, sir.
Is there any complaint regarding my class? Tell me frankly.
No, sir.
No, sir.
Not getting much response. That means some people have definitely some complaint.
No,
No, sir.
No, sir.
No, sir.
no, sir.
No, sir.
No, sir. Why?
Okay.
No, sir.
Sir.
सर जब तक फर्स्ट सेमेस्टर का रिजल्ट नहीं निकलता तब तक आप लोग कुछ नहीं कहोगे. ठीक है चलो. Now how many of you are there? It's 127 only. I don't know due to this.
29. Apato.
-1 excluding me.
Yes, sir.
Sir, আবার
127.
দুজন কমে গেল.
Okay, there might be some net related issue or some other trouble. Anyway, please share your class materials with them if anybody wants or asks. Now, do you find any blank page shared there?
Yes, sir.
Yes, sir.
Yes, sir.
So suppose we have two forces. One is F1, other is F2. Anyway, we start with same value, F and F. Now, what about their resultant? Two parallel forces.
2A.
Left.
And their position or location.
Vertically
Vertically
downward.
Vertically downward.
Vertically downward, twice F. Will it be here? Position?
No, sir.
No, sir.
Yes,
Sir,
sir,
in
it
between
can
the
be
two
quadrilateral.
forces.
Symmetrically between the two forces. So that is from our common sense. But you just think that two forces are not equal. This is F1, this is F2. Now, what about the magnitude of the resultant?
F1 plus F2.
F1 plus F2.
Now, if F1 is smaller and F2 is bigger or some larger magnitude, then definitely the resultant will be more close towards this.
F2 side.
Yes, sir. Yes, sir.
Do you agree?
Yes, sir.
No, sir.
No.
Yes, sir.
F1.
No, sir. Yes, sir.
Sir, closer to F1.
Sir, it should be close to F1 now. Balance out.
F1 is less.
No.
Yes, sir. That is why.
Sir, repeat it.
Yes, sir. By Valencian's theorem, sir.
Suppose, have you seen the children's park seesaw?
Yes, sir.
So if two of
Yes,
you
sir.
are there at two ends of that seesaw and one is heavier, so what about that?
Center of mass.
Yes.
The closer to the heavier body.
How mathematically we can do this? What about that expression?
Sir, x dash means XEC01 equal to m into x1 plus m.
That means there should be some reference
Point.
line or reference line or reference point. If it is the reference point, so from this reference point we find these distances. Suppose these are x1 and x2, whatever may be their values, we don't go to that comparison. F1 may be less than F2 or greater than F2, but that moment equation to be satisfied, that is, if this is the resultant, naturally its value will be F1 plus F2. Then if this distance is x, then what about this r multiplied by x? Definitely this overall moment to be the algebraic summation of contribution of all forces in terms of the moment. that is f1 x1 plus
f2 x2.
f2 x2. Now tell me the next thing. If by any chance this f2 is in this way, then what about the resultant?
-2 fx2.
So it goes
If we consider
F2 minus F1.
RV F1 minus F2.
if this direction,
No, sir. F2 minus F1, I think.
just a minute. So if we consider this direction as positive, then resultant will be f1 minus f2.
Negative.
Okay, so that algebraic summation. And similarly, here also, if we consider clockwise moment with reference to this point, you can say that reference point as origin. So for that, it will be f1 x1 minus f2 x2. So ultimately, it comes to be the algebraic summation. So algebraic summation of forces, algebraic summation of moments. These things with their proper sign you must remember. So is there any confusion? Beta,
No, sir. No.
jaldi bol. So
No, sir.
there should not be any confusion. Now, if there are more number of forces, simply it will be algebraic summation of all such forces. Just
Yes, sir.
erase out all these things. So this is the reference point. Along this direction, we find the corresponding location of the resultant f1, f2, etc. up to fn. So in that case, what about the location of the resultant force? That x is indicated by summation fi xi divided by summation fi. This algebraic summation indicates f1 plus f2 minus f3 minus f4, etc. So it includes that summation, algebraic summation, that positive negative signs also. Now we have simplified this expression in this way. Anyway, we should not do it in that way. First write down the actual expression. So resultant multiplied by the location of the resultant, that is moment, the overall moment corresponding to the resultant and its distance x. It is equal to the algebraic summation of all individual moments. If this distance is x1, x2, etc., and the resultant is so R will be algebraic summation of fi.
Yes, sir.
And this Rx is algebraic summation of fi xi. So algebraic summation of forces is the resultant force, and algebraic summation of all individual moments, that is the moment of that overall force resultant. Now once is find that
So your voice is breaking a lot.
the position or the location of the resultant. So x is summation So X is summation Fi Xi divided by summation Fi, which is the resultant. Is it clear now? This part?
Yes, sir.
Hello?
Yes, sir. Sir, is it Varingnom's theorem?
Yes, sir.
I don't know. I to check whether I have muted.
Sir, your voice is breaking.
No, it is not Varignon's theorem.
Varignon's
Yes.
theorem states that the resultant
Because
moment is
Varignon's
due
theorem
to
is
the
there. It is
Your voice is not
Yes, sir.
coming.
Yes, sir.
Yes,
So my voice কেটে কেটে
His
যাচ্ছে
voice is breaking, sir.
moment is
due to some of the individual moments,
Anyway,
that
is
is
it clear
resultant
now?
of individual moments.
Because I am helpless that network is giving that.
Yes, sir, it is clear.
So Varignon's theorem, it starts from two forces and its moments. Now, what about the moment? Moment is the magnitude of the force multiplied by the distance. So actually, it started from that geometrical idea that some length which represents the magnitude of the force, that multiplied by the distance. So definitely it is that perpendicular distance, and it gives area of a triangle. Do you get my point? So if this thing here is a line which represents the magnitude of that force, so that magnitude multiplied by some perpendicular distance. Now what about that perpendicular distance? If this is the perpendicular distance, then what about the product of these two quantities? This distance in this blue line and this distance in green line, definitely it is the area of the triangle.
Yes, sir.
So please repeat.
Force multiplied by distance. Perpendicular distance. So this is the force. This is the distance. If we represent it geometrically, then definitely it gives us the area of this triangle. So that moment of the force is represented by this area. And if we combine these two areas of triangles for individual forces corresponding to their individual moments, we definitely get the summation of these two areas is equal to that unique thing which gives us the product of two quantities, which is the magnitude of the resultant of these two forces and the distance of that force measured from that same point of reference. So it was that simple geometrical clue, and that geometrical clue who discovered, invented, or revisited first, he is the pioneer. So by the name of Varignon, we know it. By the name of Pythagoras, we know 3 square plus 4 square is equal to 5 square. By name of other people, we know all such things. But we must know the simple mathematics behind it. So don't blindly just take the name of Varignon's principle, which is applicable for two forces only, and somehow you can extend. Now you use your knowledge for algebra, calculus, etc. with that basic idea. Now for that case, which we utilize for Varignon, those two forces were normally not parallel. And for non-parallel forces, it is very easy to find out the point of interaction. So resultant passes through that. So the individual forces contribution corresponding to the moment that you can find, that algebraic summation that you get from Varigno's principle, that it will be the moment of the resultant force. But what about the location? We discussed in some earlier class that for location or the position of the resultant force corresponding to parallel forces, you require to resolve the individual forces. Suppose force F1 is there, which is parallel to F2. So resolve F1 in two components, suppose M and N, these two forces. Resolve second force F2 in N and P, these two components, not N exactly, it is minus N. So that algebraic summation of forces F1 plus F2 will give you M plus N plus minus N plus P. So ultimately it is summation of M plus P. And what about these two forces, M and P? These are non-parallel. So that simple approach of resolving forces, so that composition of forces, resolution of forces, composition of moments, etc. All these things I should not repeat in every class. It will kill simply our time. So please remember this thing. Okay. So first thing, we developed all these things geometrically, the graphical, and summary of those graphical thing we now presently in some mathematical shape. Now this simple algebraic equation, you can think of the vector application corresponding to those, and vector is the summarized thing where we normally remember the formula and apply them blindly, but definitely we should visualize about the problem and understand what is the physics behind it. Mathematics is not that great thing. Without physics, it cannot exist. For abstracting, of course, there are some ideas, but normally we take the help of mathematics to solve the problems of physics. So you formulate the problem of physics. For that, you need some application of some other tool, which is mathematics. Okay, so here this R resultant is the algebraic summation of all these forces F1, F2 up to Fn. Its moment about this reference point is R multiplied by that distance, location of the resultant. So that R multiplied by X is summation of all such individual moments Fi Xi. And if you now want to extend that Varignon's principle geometrically, considering apply it for two forces, directly you cannot apply, you have to resolve in M plus N and minus N plus P. Then you get the resultant, you go for the third one. So it is some Herculean task, or simply remember this algebraic expression. Okay, and from this expression, we determine this value of X, the position of the resultant in this simple expression. Algebraic summation of moment of all forces about the reference point divided by algebraic summation of all forces about the same reference point. Done? Is there any confusion? आगे चले?
Yes, sir.
Yes, sir. आगे चलिए.
Yes, sir.
Okay. Just hold for a minute. I'll be back. Some non-commercial break.
ভাই একবার একটু সামারি বলবি এটার?
हिसाब रखते हो? हिसाब रखते हो कितने हो?
एक दिन आपका 1 किलो दूध कम हो गया है, जिस दिन 4 किलो दिया था एक दिन
टोटल कितना हुआ? कैसा हुआ?
टोटल हुआ 5,580 चलिए 124 किलो दूध।
123 किलो है। एक दिन आपने 2 किलो दिया।
हाँ
सुबह नहीं आया,
हाँ
शाम को आया था 2 किलो लेके आया था।
हाँ यार
अगला दिन 1 किलो ज्यादा दिया, 5 किलो दिया। ठीक है, 9 तारीख और 10 तारीख
हाँ देखिए याद
तो 130 किलो था, 45 किलो के भीतर से 535 किलो, 1000 करके 4535 किलो रहेगा। ठीक है। So with that simple idea, we'll move forward and apply all these things. Okay. So let us erase this part. Now, how do you determine the center of gravity of any object?
Summation of M1 X1 by summation of M1 MI.
Yes, sir. The same formula basically
So
modified.
basically the same
center of
formula.
mass.
Now it depends on the object. If the object is some irregular shape, suppose stone, or some irregular shape plate. Suppose we have a plate. Or maybe before going to that curved line, let us go for some. If it is a plate, then what about the center of gravity?
In the middle of the plate.
If there is no such,
At the intersection of the two diagonals.
if there is no such individual diagonal like thing,
So it is a center only if the body is uniformly distributed.
now there are several lines. 1, 2, 3, 4, 5, 6, 7 straight lines. Then how to find its center of gravity? Now center of gravity is a fixed location or different?
Fixed location.
Fixed location.
Fixed location.
Now, if suppose this is that fixed location, suppose, so if it is that fixed location, then how we can find it? The simplest way, can anybody tell me from your common sense?
Yes, sir. We'll hold a pin beneath the hole, and if it balances, then it is the center of gravity.
You do not know this point. As you are telling that you should fix one pin and hang it through a rope or something like that. So it is hanging in this way. Then how can you say or how you determine the exact location of the center of gravity for this irregular plate?
So now draw a vertical
Sir, by
line.
wings.
Okay, we draw a vertical line.
And again change the pin location, sir.
Yes, sir.
Yeah.
Change the pin location and find the
And draw another
intersection.
vertical line. The
Find the
intersection.
intersection of the two vertical lines.
So change the pin location and find it.
Yes, sir.
Suppose here. Now it will change its orientation. Okay. So it will change its orientation and naturally it will hang in some other way. Okay. And if this is the line, now why we are drawing the lines? Because it is hanging from the ceiling with a single rope. So naturally, if we draw the free body diagram, it is subjected to the self weight W, sorry, the self weight W and the reaction, or so R is W, and similarly, when we consider this first case, in that case, this was the resultant, and along this line, the weight was acting. So this is the line where the center of gravity is located along this line. Anywhere, we do not know. And for this orientation, when it is hanging in this direction, so naturally W is acting along this line, the line of this string or the rope extended. And this is the only possibility that this becomes the center of gravity, because it satisfies that primary condition that the center of gravity is located along this line, which is the line of this rope extended, as well as the center of gravity is located on this line, which is the line of extension of this rope. So this is that common point. So definitely, so this is the primary idea. Okay. Now mathematically, how we do? Now there is one more thing. In this connection, you can remember that Archimedes experiment also. Okay. So there also similar type of idea, the force due to buoyancy, etc., and it passes through the center of gravity of that liquid displaced. Okay. So all these primary, preliminary and primitive things, it must be in our knowledge bank. And we extend those ideas and simply with our mathematical tools in our hand. Now let us erase this part also. So just to remind you about all these basics. Now, if we subdivide that plate in small segments, very small elements, then we can find the individual weights are acting through those locations. If those small portions are not very large, we can consider that particular location. It is giving us that position through which the weight of that small element is acting. And we consider in this way. Suppose there is a plate which is placed in this plane XY, and we consider different locations for those individual small weights W1 at this location 1 having coordinates x1, y1, another very small weight due to that small portion of that plate at this location 2, coordinates are x2, y2, etc. And here we consider the forces F1 and F2 parallel to each other, but these are parallel to z axis. So in this case also we can get the similar relation of our starting discussion.
Yes, sir.
Okay. So the x coordinate and y coordinate of this resultant force F, which is simply the algebraic summation of the forces F1 and F2, but some difference from the previous discussion, that simple mathematical discussion was that we considered sometime F2 is opposite to that. But for weight, the self weight, the force due to gravity, it is not acting normally until unless mathematically it is considered that F2 is not acting opposite to the direction of that gravity force direction. You get my point? So for such simple situation, if that plate is subdivided in very small portions having the weights F1, F2, F3, F4 up to Fn, then it will be simple algebraic summation of all such moments of individual forces divided by algebraic summation of forces of all such elements which are the self weights. Now we extend it for many number of such thing, not simply F1 and F2. Now this diagram is a photograph of that. It is looking little hazy. Now please take little pen. This is the overall weight W. C is the center of gravity. Its distance x, c and yc are to be determined for this irregular shaped plate. But one simplification we have assumed, that is, this plate is of uniform thickness T. So for that uniform thickness T, this plate, which is a flat plate, and we place it in that XY plane, and we can understand that all these individual forces for all such small particle-like things distributed over the whole plate is Wi, and there may be W1, W2, W3, W4, W5, etc. And XY, YI, not necessarily they will be positive always, that all these locations are on this side, that is in front of Y and above X, not in that way. It may be here. So if it is located on this side, X will be negative. If it is located on this side, X will be positive, but Y will be negative. Similarly for the third quadrant also. So you don't need to bother about that. You form those algebraic summation expression. And this is that expression. If we consider the moment about Y axis, so forces Wi giving the moment Wi multiplied by xi, that is W1 x1, W2 x2, W3 x3, W4 x4, etc. And all that contribution will give that summation to the total weight W multiplied by the distance of the center of gravity xc. Do you have any confusion? Naina?
No, sir. But sir, in the previous,
sir.
sir,
No,
but in the previous page, sir, please go to the previous page, sir. Sir, for summation of moment about y-axis, fx equal to fx1 plus f2 x2 in the second line, sir.
Oh, second line. Oh, thank you. It was not my intentional chalaki that whether you have spotted this thing or not. It is really my mistake. Okay, this one. It should be x2. Thank you very much. So there is every possibility that normally we make some jump cut like thing, as you see in the movies. Here also, when you are doing something डेफिनेटली ये तो इजी है, ये लिख लेंगे और दूसरे इक्वेशन के बारे में सोच लेते हैं. एंड फॉर दैट पैरेलल प्रोसेसिंग, when I am writing this part, I am thinking about this thing. So please never do that. Think one thing at a time, finish it, then jump over the next thing. So this summation of these moments for the individual forces, F1 x1 plus F2 x2 divided by F1 plus F2, that is the location of the resultant along x direction, along y direction. Simply taking the moment about y axis and about x axis. They might be like this. Okay. Now this is for two forces, two parallel forces. We have extended it for many number of such parallel forces. Many number means individual element and their weights, Wi, 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 etc. Many number of, but those are not infinite numbers, finite numbers. Maybe 50 elements we are considering. So W1, W2, W3 up to W50, I is equal to 1 to 50. We just get the algebraic summation, and this algebraic summation will never include any negative force here until unless there is some special situation, because weight is always acting vertically downward. Now, if we consider this element is very small, its location and its individual center of gravity, they are exactly the same location. So we eliminate that possibility of difference between its location and its center of gravity by considering them very small. And for those very small weight, we consider them in this integral form as summation Wixi is integration x dw. And similarly, summation Wi is integral dw, the total weight. Okay. And yc also like this. Now, here we have not considered one thing, that is, we are considering the point C is on the surface, but truly it is not. Where it is located? It is located, it is located at this level. Okay. And if we consider that middle plane is the XY plane, in that case, truly we are using this expression for that particular coordinate system when the origin is located in the middle plane, that is at the half thickness of the plate, and the plane XY is parallel to either of this surface or this middle plane on which it is located. Okay. Now, if we consider that we are considering a finite element AI, area AI.
Sir,
Yes.
sir, gravity अगर नीचे দিকে কাম করছে তো এয়ার রেজিস্ট্যান্সটা উপরের দিকে করবে না?
We are not considering that air resistance, or we are not.
Center of gravity.
We are talking about center of gravity. We are neglecting the effect of location, our latitude, longitude, because if this plate is too big a horizontal plate, for that Earth's surface, it will be a tangential plane to that sphere. If we consider a small ground, suppose your football ground, there on the surface of the Earth, truly speaking, it is the portion of a sphere. Okay, but all those things we are not including here. We are moving in that area where the dimension is really too small compared to the radius of the Earth, and all these forces are not acting towards the center. As you see, the sun rays coming from that big spherical source of light, those are radially outward. But for that big size compared to our Earth, we are considering them that coming parallel to each other. Similarly, here also, if we consider a big plate, suppose the plate is of the size of your state. Which state you belong to, beta?
Sir, West Bengal, sir.
West Bengal. So through Durgapur, there is the weight of Durgapur. That area is passing through the center of the earth. Similarly, weight of Kolkata is passing through the center of that. So all these lines are not parallel to each other. Those are radial, inward. But for small dimension, these are parallel to each other, and we concentrate on this part only. Okay, these are all vertical downward. Now, next thing, very important thing, that is, I will forget to take your attendance. Let me do it first. So it is showing that it has been downloaded, but I'm not going to check it because it will kill some time. Now, this force Wi, if we consider there is a small area, then what about the weight of this small element? The volume multiplied by unit weight?
Yes, sir.
So that volume multiplied by that unit weight, which is the weight Wi. What about the volume of this element? It will be a prismatic element. Area Ai and its depth. What about the length of its this prismatic element? It is the thickness T. So the small volume is Ai multiplied by T. That Ai multiplied by T. Anyway, it might be difficult for you. So volume this thickness is constant, it is uniform. Now what about the weight? Wi is volume multiplied by weight density or unit weight. That is Ai multiplied by T. That normally we write it in this notation gamma. Okay. So that Wi is Ai multiplied by T, that is the volume multiplied by gamma. What about its force? Its contribution in that moment? It is XIWI, that is XIAI gamma. And what about the total force? XC multiplied by W is that same thing. XC multiplied by total area multiplied by thickness, it is the total volume, that multiplied by gamma. And what about the location distance of the centroid, the center of gravity measured along x-axis? Simply that ratio, algebraic summation Wixi divided by algebraic summation Wi, and it is written in this form. Total weight is total volume multiplied by gamma, here At gamma, and individual weight of the element Wi is Ai multiplied by T, that is the volume of that element, surface area multiplied by the thickness, uniform thickness T, that multiplies gamma, where C is the center of gravity, T is the uniform thickness, gamma is the unit weight. And this Xc is in this algebraic form, that is finite number of elements, maybe I is equal to 1 to 50 or 1 to 60, something like that. So it is Xi Ait gamma divided by summation Ait gamma. Now this part is very important. From numerator and denominator, we cancel out these two non-zero terms. So it becomes this expression for finite number elements, summation xi divided by summation ai. And for infinitesimally small elements, we use the idea of calculus integral x dA divided by integral dA. So integral ai, summation ai or integral dA, they will be the total area. Now, this part is very important. This area part. If we talk about this summation xi ai and summation ai, is there any force contribution? Is there any such self weight or any other thing? Mathematically, it is area only.
Yes, sir.
So, which area? Area of that middle plane in which the center of gravity is located. And for that uniform thickness T, that plate, we consider the middle plane at a half T thickness, center of gravity is located, and that point is indicated by this summary of this expression. For the middle plane area, its subdivision in finite or infinite number of elements, either ai or delta a. So these expressions are very important, and this expression where area is there only, it is called not center of gravity. Corresponding to this area, it is called centroid. So area of the centroid, the numerator part, xiai, definitely it is coming from the moment of that force wixi, but area is not that force or weight. So what about the name for this xiai? It is called area moment. Now area multiplied by distance, it is called area moment or moment of area. And there is one more thing, we will discuss it later, not now, but it is there, that area multiplied by distance square, this is second moment of area, and this is first moment of area. Okay, this is simple mathematical equivalence, which is the surface property or area property. Centroid, which is something equivalent to the center of gravity for a surface, a flat surface where there is no thickness, where there cannot be any volume, where there cannot be any weight. But mathematical equivalence is that the centroid of that plane area is integral x dA over integral dA. That is the distance of the centroid along x-axis, and distance of the centroid along y-axis is integral y dA divided by integral dA. Very important thing we must remember, and you, before our next class tomorrow, please go through any book on engineering mechanics, that chapter on centroid. So centroid, first moment of area, second moment of area, all these things are very important, and it has enormous application for engineering practices. Okay, so please have some rather knowledge before the class. Okay, so that while discussing, you can participate it. Okay, so that is the simple idea. We started from these two forces applied at two locations, x1 and 2, having the coordinates in that xy plane, f1, f2, and this is the resultant, and we extended that simple idea of this, of course, with this correction you must note. Okay, so distance of the location of the resultant force indicated by xc. It is F1 x1 plus F2 x2 divided by F1 plus F2. And if we consider there are so many forces at different location, if we